Yeah, so question 23 from the practice exam. We're given this information that I've got 530 milligrams of vitamin C, and I have that in 125 milliliters. They tell us, right, vitamin C is a polyprotic acid, so there's two Ka values. Ka1 is 7.9 times 10 to the minus 5, and Ka2 is 1.6 times 10 to the minus 12. The first thing we can do is basically this second Ka value is so small, we can just ignore that when trying to figure out our pH in this polyprotic acid. But what we do have to do to find pH, we have to find concentration. So concentration, right now I've got mass, I've got volume, concentration is moles per liter. So we have to find molarity. To find our concentration, I can't do that with milligrams, so I have to convert that to grams. So I've got 0.53 grams of vitamin C. I need to convert that, right, to moles. So I know the molar mass of vitamin C. For every 1 mole of vitamin C, I've got 176 grams of vitamin C. So that cancels out. And I'm going to have approximately 3 times 10 to the minus 3 moles of vitamin C. So we found moles. Now I need to find my concentration, which is molarity. I need to use the volume now. So, all right, I have 3.01 times 10 to the minus 3 moles, and that's in 125 milliliters. Molarity is moles per liter. So, all right, that many moles in 0.125 liters. So I'm going to divide by 0.125 to get my concentration of vitamin C, about 0.024 molar vitamin C. Now we have concentration. Now, right, we're asked to find the pH of this solution. So now this is like any weak acid question where I have Ka, I have my concentration, and I'm asked to find pH. So to find the pH, we need to find hydronium. So we know, right, Ka is hydronium times the conjugate base all over my weak acid, right? I know Ka1, right? Ka1, 7.5 times 10, 7.9 times 10 to the minus 5. I don't know hydronium. I don't know the conjugate base, right? But they should be the same. They're formed in a 1-to-1 ratio. So I can say X, and then for my concentration of my acid, right? That 0.02409 molar is my concentration. So I'm going to multiply that across. I get X squared equals 1.9 times 10 to the minus 6. Take the square root of both sides, and I get X equals 1.379 times 10 to the minus 3, right? What is X? X was my hydronium concentration. So now that I have hydronium concentration, now I can find pH. So step 4, right? pH equals the negative log of hydronium. So the negative log of 1.379 times 10 to the minus 3. The pH of this solution should be something like 2.86. So we had to find, there was a question in the homework like this as well, where they gave you mass, they gave you volume. We had to turn that into moles, turn it into concentration. And then once we found the concentration, we could find the pH of that doing a standard, right? We've done step 3 and 4 a number of times. Step 1 and 2, which are probably a little bit harder. And then the other thing, right, our weak acids, that Ka value, Ka1 is, right, the only Ka we need to worry about because that's the largest Ka. Ka2 is so much smaller, sure, we could go through this process again. But the concentration we would get from that is really not going to change this pH, because that value is so small. The X we would find, and doing this a second time with the second Ka value is not going to change that pH significantly. So yeah, for question 23, we should be, pH 2.87, 2.86, something like that.